Okay, so I'm just going to summarise what we've been doing in case study 1. Now, this is just for the steam side, for the Society Steam and Speed. And what does the community of Doncaster owe to the railway? Our first case study 1 learning target was being able to explain the force variables that affect a train journey. And we started doing that by establishing exactly what a force was. And after we found out that a force was a push or a pull, we then started to look at those forces in a little bit more depth. So all forces have a direction and a magnitude. Because of this, we often get a resultant force, and this means there's an overall effect of the forces when they are acting together in a system. And we demonstrated this by doing a class tug of war, with the balanced and unbalanced forces, and this explains the driving force of a train and how it can move forward. So then, the first force we looked at was friction. Now, friction always resists movement, so it always works in the opposite direction to movement. And friction is used by trains by gripping them to the surface or stopping movement by the brakes. But it also would restrict how fast something can move by acting as air resistance or drag. And also friction would waste energy on trains by generating heat. Now, air resistance is a type of friction. And we actually looked at an air resistance investigation used in helicopters. Now, air resistance is a force that also acts in the opposite direction of travel, and we found that increasing the wing length and the surface area of the helicopter wings actually increases air resistance. So the same is true for the front of trains, which explains the development of streamlined modern trains such as HS2. We next looked at energy conservation, and we found that energy cannot be created or destroyed, but it can only be transferred from one form to another, and it's measured in joules. And we did this by looking at gravitational potential energy transferring into kinetic energy. And we did this by swinging a pendulum, which is applied to a train, for instance, at the top of the hill, which the gravitational potential energy is transferring into kinetic energy as the train starts moving. Later in the expedition, we'll be looking at different types of energy transfers within steam trains as well. Now, as well as these energy transfers, we also looked at the relationship between mass, weight, and gravitational field strength. And we found that gravitational field strength is always 10 on Earth, 10 newtons per kilogram, and weight is actually the force, and mass is the stuff that something's made of. And that would explain why an astronaut only weighs far less on the moon than he would do on Earth. And that's because his mass would stay the same, but his weight would be different because the force of gravity is different. Now, being able to explain the force variables that affect a train journey will be key when creating our final product, as they'll explain the causes of death by people who have been killed by trains in Doncaster whilst working on the railway.